welcome back to Math Partake. If this is your first time checking out my channel, make sure to press the subscribe button right away so you don't miss out on any weekly math posts. Now, today's video is part of a series on basic functions. If you clicked on this video, your teacher probably gave you a set of coordinates that looks something like these and asked if the set is a function or not a function. So today I'm going to go over what you need to know before completing an example like this, what your answer should look like in the end, the steps to completing this example, and a couple more examples that require the same process but look slightly different. So let's talk about what you need to know. First thing that you need to know is the definition of a function. Now, the definition of a function is a relationship between one or more variables where the x value does not repeat. Now, when I talk about variables, I mean letters that represent numbers, like an x or a y or a z or a k or whatever letter that you want to choose. Now, the second thing that you need to know is how to create an xy table. And if you're not sure how to create an xy table, we're actually going to go over it in the problem anyway. Now, in the end, your answer is simply going to be either no, this is not a function, or yes, this is a function. So let's take a look at our first example where it says, does the set represent a function? Now, what we have in front of us is a set of coordinates. Each coordinate altogether collectively create this entire set. We have 5, 5, 6, 16, 3, 21, and then we have our final coordinate, which is 9, 100. So what I like to do as a step one is to label each coordinate with an x or y, okay? So we know that the first term in each coordinate is an x, and the second term in each coordinate is a y. And we're gonna do this on all the other coordinates throughout the entire set. X, y, x, y, x, y. So that just shows us that the 5 is an x and this 5 is a y. This 6 is an x. This 16 is a y. The 3 is an x. The 21 is a y. The 9 is an x and the 100 is a y. Step 2, we're going to create an xy table based on the coordinates in the set. And this is what it looks like. X, y, this is our table. Okay? And we see that our first x is a 5 and our first y is another 5. I got that from right here. Our second x is a 6. Our second y is a 16. And we have a 3 and we have a 21. Remember, I'm getting everything from our set of coordinates all along here. Then we have a 9 and a 100. Okay? Now, step 3 is that we're going to look at this XY table that we just created, and we're going to decide whether this is a function or not. So what we're really focused on is this side of the table where you have the X values. If you see an X value that repeats, meaning that if we see a number that shows up more than once on this left side, these X values, that means that the X repeats and it's not a function. So let's quickly take a look. We see that we have a 5 here, and there's no other 5 in the list of X values, which is also called a domain. The list of X values can be called a domain. You don't see any other 5s in the domain, so that's good. We have a 6, there's no other 6s in the domain, so that's good. We have a 3, there are no other 3s in the domain. That's good. We have a 9, and there's no other 9s in the domain. So that too is good. So this means that the X value does not repeat. Therefore, this is a function. So the answer is yes. This is a function. Let's try another example. Okay, now this example here, we're gonna follow the same process. Okay, our step one, we're gonna label each coordinate as an X or Y. X, Y, X, Y, X, Y, X, Y, X, Y, X, Y. Our second step is creating our XY table. So X and Y, okay? All of our X values are gonna go on the left and all of our Y values are gonna go on the right, just like a coordinate. So in the first one, we see a 4 and a 3. Then we have a -1 and a 4. Then we have a 1 and a 7, 9, 11, 1, 10, and 5, 2. And real quick, what I like to do sometimes is actually go and look back and just make sure that all my X values match up with the Y values. I've already done that in my head, so I know for sure that they match up. I suggest that you always go back and just double check. So let's look at our next step. Our next step is to, again, look at this XY table and see if any X values repeat. Let's do it. We see that we have our first X value as a 4. The question that you should be asking yourself is, are there any other 4s in this list of X values in this domain? And the answer is no. We can do the same thing for -1. We see it here and we say, okay, there's no other -1s. So 4 and -1 are good. Let's take a look at 1, which is our next X value. We have a 1 here, and as we slide down, we see there's another 1 right here. That means that the X value is repeating, and this is not a function. And that's our answer. We don't have to go any further. No, this is not a function. That is your answer. Okay, so our third and final example of does the set represent a function is going to be what you have in front of you here, which is a set of coordinates that include fractions, decimals, letters, and negatives. The things that so many math students hate. But I'm going to show you how simple it is, and that as long as you understand the process, it really doesn't matter if you throw a negative or a decimal or a letter. It doesn't matter. The process is still the same, and you can still get 100% on your exam. Okay? It's 1/2 here, and it's the first term in our coordinate, so we're going to label it an X. We have a 2, we'll label it a Y. Then if we look over at our next coordinate, there's still X and Y. Do not let that confuse you. Now we switch it up even more. We have an A and a B. We can still consider it an X and a Y. That is the beautiful thing about math. It can be very mechanical. As long as you understand the process, you're good. X and Y, same thing. So our process should be smooth. We go right into our next step where we have our XY table. And we can go 1/2 and 2 for our X and Y values. Then we say 3.5 and 2.5 for our next set of X and Y values. Then we have A and B, which are letters, but they still represent numbers. Then we have -3 and 6, all XY values. And we see that we have a 1/2, we have no other 1/2s. We have a 3.5, we have no other 3.5s. We have an A, no other A's. And then we have a -3, no other -3s. So the answer is simply that there's no X repeating. So this is a function. Yes, this is a function. And that is our answer. Listen, thank you so much for watching this video. If this video helped you understand how to identify if a set is a function or not, like, comment, and subscribe. And I'll see you on the next video.